and graph system of equations today. A system of equation is when it's two equations that are graphed, or two equations, two situations in which you have a value that represents a solution to both equations or both scenarios. So for here, the first thing I want to go over are the types of system solutions, the different types of system solutions. So one solution, the one solution system means that you're going to have a graph of intersecting lines. So you have two lines that are plotted, and that point of intersection is going to be called the solution. Okay, now it's important to understand that with one solution systems, they have different slopes. The slopes for those two lines are different. They might have the same y-intercept. That's a possibility. But the only thing that's important to understand is that the slopes are going to be different. So if you're given two equations and they are only asking you what type of solution is it going to be, is it going to be a one solution, a no solution, or infinitely many? If you look at the slope of both equations and they are different, then it automatically is a one solution system. They just have to have different slopes. The no solution system. No solution system means that they're going to be a set of parallel lines. They will be a set of parallel lines, which means they're going to have identical slopes or the same slope. Both lines will have the same slope, but they will have different y-intercepts. Their slopes will be identical, so that means that the direction that they are moving is the same, but their y-intercept values will be different. That's what makes parallel lines. Lines have same slopes, different y-intercepts. And then you have infinitely many solutions. Infinitely many solutions. So when you're looking at infinitely many, you only see one line, and that's because for infinitely many, the two equations simplify to being the exact same thing. They become the exact same equation, meaning that they will have the exact same slope and they will have the exact same y-intercepts. Their slopes will be identical, their y-intercepts will be identical, meaning it will create an identical line. So even though it might be two separate equations or two separate situations, they come out to an identical graph. Now, as always, I like to go ahead and give you that reminder of how to graph an equation. Remember, you must first graph your y-intercept. I'm going to highlight that in pink, that first step. That's always our first step. We always graph our y-intercept first. Then we use the slope as directions in order to be able to graph the next set of points. Meaning that if you have a positive slope, then that means that you are going to go up and you're going to go to the right. You're going to go up and go to the right. Or you would have a negative over a negative, which means you would go down and then you would go to the left. When graphing positive slopes, that means that you're going in both positive directions or both negative directions. Both positive direction or both negative direction. If you are graphing with a negative slope, That means you have opposite directions. When you have a positive rise, it will be a negative run. So it means you will go up and to the left. Or the reverse, you can have a negative rise and a positive run, which means you will go down and then to the right. So those are just some key reminders on how we graph. We want to keep going over those over and over and over again because you will be doing that soon. All right, let's go ahead and take a look at the next slides, those slides off to the right. Mrs. Baker, so we're going to start off with just going ahead and translating, writing these systems. Mrs. Baker bought 14 boxes of red and green paper. There are a total of 72 reams of paper. So when you buy a box, it comes with reams of paper. So reams of paper are things like this, all right? This is a ream of paper. It comes in a plastic wrap. So I buy a box and I might have several reams of this paper inside, okay? So the box for the red paper, the red boxes are going to come with 6 reams each. So 6 packs of paper inside each box. And the green boxes are going to come with 4 reams each. So 4 packs of green paper in each box. We're going to identify our variables for X and Y, and then we're going to write a system that is going to represent the situation that has been stated here. So the very first thing that we want to do is identify what our variables are going to be, meaning our X and Y values. So for here, because I want to do the first one with you, we're going to identify the variables. So I'm going to go ahead and let X equal red, and I'm going to let Y equal green. I'm going to let X stand for red, and Y is going to stand for green. Okay, now the first thing I'm going to do is go ahead and identify the first statement that they gave to me here. They said that she has 14 boxes of red and green paper. 14 boxes of red and green paper. So for that statement, I'm going to write that down. 14 boxes of red and green. That means if I add the red boxes and the green boxes together, it should equal 14. So my equation for here is going to be X plus Y is equal to 14. 14 boxes of red and green. I'm just going to take my reds, take my greens, add them together, and that should be coming 14. Okay, my next statement on here. There are 72 reams of paper, and the red has 6 reams each. The green has 4 reams each. That's the next set of information that I've got. So I have 6 each for the red. I have 4 each for the green. And it's going to be a total of 72. 6 each for the red and 4 each for the green with a total of 72. So that means when I'm making this equation, it's going to be 6x, that's 6 per red, plus 4y, because that's 4 per the y, per the green, and that's going to equal 72. So there's my next equation. And then that's it. I just wrote my system. So my 2 equations are just x plus y equals 14 and 6x plus 4y is equal to 72. All right, let's continue on. Greg's Motors has motorcycles, which have 2 wheels, and then they have ATVs, which have 4 wheels. The store has 45 vehicles that all together have 130 wheels. We're going to identify our X and Y variables and then write the system to represent the situation. So again, it does not matter which value we represent as X and which one we represent as Y, as long as we identify that. So here I'm going to go ahead and indicate that X is going to represent my motorcycle. And that Y is going to represent my ATV. X is going to represent the motorcycle, Y is going to represent the ATV. Okay, so then we're going to split it out into what the different statements are. So we have one statement that says, hey, we've got a total of 45 vehicles. Okay, so I know if I take the number of motorcycles and the number of ATVs and combine them together, it's going to equal 45. So X plus Y is going to be equal to 45 because we have 45 total vehicles. Then I know that I have a total of 130 wheels, where a motorcycle has 2 wheels and an ATV has 4 wheels. So again, X is representing my motorcycle. There are 2 wheels per motorcycle, plus the 4 wheels per ATV, and that's going to come out to 130 wheels. And there's my system. I want you guys to try number 3 on your own. Okay, let's take a look here. If Creative Crafts gives scrapbooking lessons for $15 per hour plus $10 supply charge, Scrapbooks Incorporated gives lessons for $20 per hour and no additional charges. So we need to verify our X or identify our X and Y variables and write the system. So for here, I'm going to let X is going to represent the number of hours because I know I'm talking about, hey, $15 per hour, $20 per hour. So I'm going to let X represent the hours. I'm going to let Y represent the final cost or the total cost. Okay, now when I'm writing my very first equation, my first equation is going to be for Creative Crafts. So Creative Crafts gives lessons for $15 an hour plus $10 for a supply charge. So it doesn't matter how many hours you are at their scrapbooking lessons, you only pay the $10 one time. So for theirs, it's going to look like Y is equal to 15X plus 10. Y is equal to 15X plus 10. Then we've got Scrapbooks Incorporated. Scrapbook Incorporated gives lessons for $20 per hour and no additional charges, so no supply charges. So for that one, it's just going to be Y is equal to 20X. So there's our 2 equations. Any questions so far? Okay, go ahead and flip the page and do problems 4 and 5 on your own. Let's take a look at what these ones are. For problem 4, homecoming dance at Liberty High School happened last Saturday. Many students bought tickets in advance for $5 each. Other students bought tickets at the door for $7 each. In all, there were 290 students that attended the dance, and there was $1,790 was the total for all ticket sales. So we need to identify our variables and write our system. So I'm going to let X, in this case, represent my advance purchase. And I'm going to let Y represent at the door. So the students that purchased in advance and the students that purchased at the door. That's going to be my X and my Y. Now, I know that there's a total of 290 students that attended. So for the total of 290 students that attended the dance, I'm going to take the number of people who purchased them in advance I'm going to take the number of people who purchased it at the door. I'm going to add them together, and that comes out to 290. Then I know that the people who purchased in advance, it was only $5 each. People who purchased it at the door, it was $7 each. And there was a total of $1,790 for the ticket sales. So that means I'm going to write the equation as $5 per advance ticket plus $7 per at the door ticket, and that's going to equal $1,790. Okay, for problem number 5. Let the present age of Alex and Ben be A and B respectively. So A is going to represent Alex, B is going to represent Ben. So they're already identifying the variables for you. Alex is 2 more than 2 times as old as Ben. So if I write that statement down, I'm just going to write that statement right here. Alex is 2 more than 2 times Ben. Okay? Alex is 2 more than 2 times as Ben. Alex is the variable A. Is an equal sign. 2 more than means I'm going to do plus 2. And then 2 times Ben means I'm going to do 2B. So there's my equation for Alex is 2 more than 2 times Ben's age. I'll highlight that statement right here. Now, in 8 years, the sum of their ages is going to be 60. In 8 years, the sum of their ages is going to be 60. So that means if I take Alex's age and add 8 years to it, and I take Ben's age and add 8 years to it, and then I add those together, that's going to be equal to 60. 8 years later means both people have to increase their age by 8. And then you can add their ages together to get 60. All right, so that's enough of translating. Let's go ahead and work on graphing and identifying solutions. So let's take a look at problem number 1 on this side for graphing. Remember, when we graph, we plot first our y-intercept, and then we use our slope to plot the rest of the points. So for here, y is equal to 2/3 x plus 3, and then 3y is equal to 2x plus 15. I'm first going to start off with this equation. So right up here, y is equal to 2/3 x plus 3. I'm going to write it up at the top so that way we have some room. My y-intercept is going to be at 0, 3. My slope means I'm going to go up 2 and to the right 3, or the direct opposite, down 2 and then to the left 3. So when I'm graphing, I'm going to start off at positive 3 for my graph. I'm going to zoom in real quick to here, and I'll zoom back out so you can see the equation again. I'm going to start at positive 3, and then I'm going to go up 2, 1, 2, to the right 3, 1, 2, 3. There's my next point. I'm going to go up 2, 1, 2, to the right 3, 1, 2, 3. There's my next point. Or I could go down 2, 1, 2, to the right 3, to the left 3, 1, 2, 3. And there's my next point. Now, I can continue to graph each of those points by using the slope, or I can just connect them carefully with a straight edge. If you're going to continue to just by connecting, be mindful that sometimes when you guys draw your lines, you're off a little bit. So you want to make sure you're very careful about which points you're going to. So it should have been here. See, I even got it off a little bit. 1, 2, 1, 2, 3. Okay. Now, for my next line, we have 3y is equal to 2x plus 15. So for 3y is equal to 2x plus 15, I'm going to go ahead and rework this problem or rewrite this problem so that my y is by itself. I want to go ahead and get y isolated. In order to get the y isolated, I need to divide everything by 3. I'm going to divide every value by 3. So that gives me y is equal to 2/3 x plus 5. Notice they have the same slope. So if they have the same slope, what is that going to create? If it's same slope but different y-intercepts, no solution, right? It's going to create a no solution. I should be able to plot it as parallel lines. I'm going to have my y-intercept at 0, 5. I'm going to have my slope going up 2 and to the right 3, or direct opposite. So when I'm graphing this one, it's going to start at 5, and I'm going to go up 2 to the right 3, up 2 to the right 3, up 2 to the right 3. Okay, so again, it's going to create a set of parallel lines. So that means that they are never going to intersect. They're never going to touch each other. There is absolutely no solution. So on here, I'm going to write no solution. Once they are graphed, there is no solution. Okay, I want you to do the next 3 graphs on your own and identify what the solutions are. If it comes out to where it's one solution and it intersects, what does it intersect at? All right, let's go ahead and go over these. For the problem number 2, we have y equals 2x plus 1 and y equals 3x minus 6. They do not have identical slopes. They do not have identical y-intercepts, so that means that we don't have to worry about it being one of those no solutions or infinitely many solutions. The y-intercept for one of them, for the first equation, is 0, 1, and the slope is going up 2 to the right 1 or down 2 to the left 1. For the second equation, the y-intercept is at 0, negative 6, and the slope is up 3 to the right 1 or down 3 to the left 1. So when we graph this, let's graph the pink line first. We're going to graph at a positive 1 for my y-intercept. And then I'm just going to go up 2 to the right 1 continuously. And then the reverse, down 2 to the left 1. Okay, that creates this lovely little line here. I'm going to go ahead and connect. Okay, for my second equation, I'm at 0, negative 6 for my y-intercept. And then I'm going to go up 3 to the right 1, 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 up 3, 1, 2, 3 to the right 1, and I'm going to keep going, up 3, 1, 2, 3 to the right 1, until eventually I'm going to make an intersection. So again, if I were to continue my pink line, and then graph my green line, it is going to connect. Okay, so it is a lot. It's a lot to get up to there, but it does eventually connect here at the following point. Okay, so there's our intersection. That's going to be at a positive 7 and then a positive 15. So there's our solution. Our solution is at 7, 15. Okay, let's take a look at the next one. You have y is equal to x plus 3 and y is equal to negative 2x minus 3. Here are my y-intercepts. Here are my slopes. Let's start off with graphing my pink line at a positive 3 for my y-intercept. And I'm just going to keep going up 1 to the right 1, up 1 to the right 1, or down 1 to the left 1. Okay, and there's the pattern that it's going to follow. Okay. For the green line, I'm at negative 3. And then it's going to go, I can go up 2 and to the left 1, up 2 to the left 1, and then up 2 to the left 1. Okay, I can keep following that pattern. And it creates this line. And then there's my point of intersection. Okay, so we intersect at negative 2, positive 1. And that would be our solution. Okay, looking at the last graph, you have to rewrite the second equation, right? And the first equation. First equation says y minus 6 is equal to 2x. So I'm going to add 6 to both sides, and I get y is equal to 2x plus 6. Then for my second equation, I have to distribute that 2 first. So by doing 2 times x and 2 times 1, I get 2x plus 2. But then I have a plus 4 on the outside of that. So now I have to add the 2 and the 4 together, and I get, again, another same equation, 2x plus 6. So when the equations are identical, what does that create? What kind of solution is that? What kind? Infinite solutions, infinitely many. Because when you graph them, they're just going to overlap, right? Because they're identical to each other. We have the 6, and we're going to go up 2 to the right 1, up 2 to the right 1. And it doesn't matter because, again, I'm going to graph it at the 6, and then up 2 to the right 1, up 2 to the right 1. And it's just going to create an identical line. And then there's our graph. So it's just infinitely many solutions. So today you're going to have a quizzes in which you are going to be translating. You're going to have to translate word problems into the correct system. And you're going to have to identify what the solution is from graphs. Go ahead and grab your computers.